Every morning, the world wakes up in light. The sky glows blue, clouds shine white, sunlight reflects from oceans, cities, mountains, and faces. Light surrounds us everywhere. It feels natural, normal, almost permanent, and yet, just beyond Earth's atmosphere, there is darkness, an endless black void stretching across the universe. A darkness so deep that astronauts describe it as almost unsettling. But this creates a strange paradox. Because the universe is filled with stars, billions of galaxies, trillions of suns, explosions brighter than entire galaxies. So if the cosmos contains so much light, why does space look dark? Why isn't the sky glowing in every direction? Why does Earth feel bright and alive, while the universe itself appears cold and black? This question may sound simple, but the answer reveals something extraordinary, something about light, about space, about time, and even about the birth of the universe itself. Earth feels bright because we live inside an atmosphere. The sun emits enormous amounts of energy every second. In fact, every second. The sun releases more energy than humanity could use in millions of years. This energy travels through space as sunlight. When sunlight reaches Earth, it enters our atmosphere and something important happens. The atmosphere scatters light. Tiny molecules in the air collide with incoming sunlight, redirecting it in every direction. This process is called Rayleigh scattering. Shorter wavelengths, especially blue light, scatter more easily than red light. That is why the sky appears blue during the day. Without this scattering effect, Earth's sky would not look blue at all. It would look black, even in daytime. Astronauts on the moon experienced this directly. The sun was shining brightly above them, yet the sky remained completely dark. No blue atmosphere, no scattered light, just blackness. This means something extraordinary. The blue sky above Earth is not actually the natural appearance of space. It is an illusion created by our atmosphere. Earth wraps us in scattered sunlight, making the world feel bright and alive. To understand why space is dark, we first need to understand light itself. Light is a form of electromagnetic radiation. It behaves both like a wave and like particles called photons. Photons travel at the fastest speed possible in the universe, nearly 300,000 kilometers per second. In 1 second, light can travel around Earth more than 7 times. And yet, despite its incredible speed, light still takes time to travel across space. Sunlight takes about 8 minutes to reach Earth. The nearest star beyond the Sun, Proxima Centauri, is over 4 light years away, meaning the light we see from it tonight began its journey more than 4 years ago. When you look into space, you are looking backward in time. Every star is a memory. Every galaxy is ancient history. At first glance, space appears empty, a giant black void. But space is not truly empty. It contains gas, dust, radiation, magnetic fields, dark matter, and billions upon billions of galaxies. The reason space looks dark is not because light is absent. The reason is because space contains very little matter to reflect light towards your eyes. On Earth, light constantly bounces everywhere, off walls, clouds, roads, trees, people. Everything around us reflects sunlight, but in space, there are very few particles, very few surfaces, very little scattering. Light travels silently through the vacuum, often without interacting with anything at all. This creates one of the strangest truths in physics. Light can exist all around you, without being visible. Imagine shining a flashlight through a perfectly empty vacuum. You would only see the flashlight itself, not the beam, because the beam becomes visible only when particles scatter the light toward your eyes. This is exactly what happens in space. The light is there, but empty space itself does not glow. Centuries ago, astronomers became obsessed with a disturbing question. If the universe contains infinite stars, then why is the night sky dark? This mystery became known as Olber's paradox. The logic seemed impossible to escape. Imagine looking into the sky in any direction. Eventually, your line of sight should end at a star. And if stars exist everywhere, then the entire sky should blaze with light. But it doesn't. Instead, most of the universe appears black. For a long time, scientists had no answer. Until humanity discovered something revolutionary. The universe is not infinitely old. It had a beginning about 13.8 billion years ago. But there is another reason space appears dark. The universe is expanding. Galaxies are moving away from one another. And as space expands, light itself stretches. Its wavelength becomes longer. This process is called redshift. Visible light can stretch into infrared radiation, then microwaves, eventually becoming completely invisible to human eyes. This means ancient light still exists, but much of it has shifted beyond what we can naturally see. The universe is filled with invisible light. Our eyes simply cannot detect it. In reality, human vision captures only a tiny fraction of the electromagnetic spectrum. We cannot naturally see infrared, ultraviolet, X-rays, gamma rays, radio waves. The cosmos may look dark to us, but to other instruments, the universe is glowing with energy. Astronauts often describe space as intensely black, even while floating in direct sunlight. This happens because space has almost no atmosphere. No scattered light softens the environment. No blue sky diffuses brightness. Instead, space creates extreme contrast. Objects facing the sun become incredibly bright, but areas outside sunlight fall into pure darkness. Shadows in space are sharper, deeper, and more absolute than anything on Earth, on the Moon. Astronauts experienced this directly. Bright sunlight illuminated the lunar surface, yet only a few meters away, shadows became almost completely black. Space is a universe of extremes. Extreme brightness, extreme darkness, extreme emptiness. So why is Earth full of light while space remains dark? Because Earth has an atmosphere that scatters sunlight. Because space is mostly empty. Because light requires time to travel. Because the universe had a beginning. And because the cosmos itself is still expanding. The darkness of space is not a flaw. It is evidence that the universe is ancient, dynamic, still evolving. When you look into the night sky, you are not simply looking into darkness. You are looking into distance, into history, into time itself, and perhaps that darkness is what makes the stars feel so extraordinary.